Hi everyone, this is Babaiah, Assistant Professor of EC Department, MLR Hyderabad. Today I am going to explain about the stability analysis. In previous session, we learned the time domain specifications or time analysis. Right, all the time domain analysis or time response analysis. From that time domain what are the time domain specifications, are there steady state errors, so what are the problems related that all these are learned from the previous sessions. Right now, today just basic stability analysis. Now I am going to explain the stability analysis. Let's move on to the first. Here the overview of today's session is what is mean by stability and what are the types of systems or stability systems. Based on the stability condition, what are the types of systems are available in control system. Now we are going to see these two. What is mean by stability systems? Stability systems are nothing but the bounded input. For bounded input you will get the bounded output. Then the type of systems are nothing but the stable systems or stability systems. Simply we say that here the a system is said to be stable when the output is in under control. Then the type of systems are said to be stable systems, otherwise we call it as the unstable systems. Stable systems produces always bounded outputs for the bounded inputs. Here see the figure, just a unit step a response of first order system from 0 to 1 value. These are the bounded output values, right? So here t equals to 0 is the all the positive values here. So that's why t equals to 0 is the input, nothing but bounded input, and 0 to 1 all the values are output values, bounded outputs. Then this figure of the first order control system response is a stable system. Simply we say that the stable system, right? Next here I am going to draw like this. Just observe, this is what a ramp signal, but here input is finite, but output is, it is infinite series, it is increases and ended somewhere, so that is the infinite. So this type of systems or signals are nothing but the unstable systems. For example, here sinusoidal signal, this one also stable system, because of here the bounded range of outputs are getting for the bounded input, so we call it as this is the stable system, right? Next here, see types of systems based on the stability condition. Simply we say that, or we are going to categorize the systems based on the stability condition. First one is the absolutely stable systems, and conditionally stable systems, and marginally stable systems, all these three, right? Or unstable system also one more is there. So absolutely, conditionally, marginally, and stable systems are unstable systems. So all these are the types of systems based on the stability condition. Here generally I'm going to draw like this. Here for example graph is like this. So this is stable or unstable, because of here input is bounded but output is going to be increases continuously, so that is nothing but the, it is the infinite range of the sequence or signal. So that type of system is the unbounded or else unstable systems. So simply, next for example I am going to draw like this. I am going to draw like this. So this is the bounded or unbounded system, simply. So here t starting point is t equals to 0, here voltage. So t equals to 0, but value t equals to 1, 2, 3, and so on up to infinity value. So infinite series. This one also unstable system output. Here also unstable system output. Only sinusoidal, for example I am going to draw like this. This is the stable system, right? And unit step also, unit step, this one, range up to here. So we need to find all these output values, nothing but the bounded outputs. So this is also stable system. So stable systems, simply we say that if any poles are based on the poles, how to divide these stability systems or systems. If the poles are present at the left side of the S plane, in all the poles present or lying on the left half of the S plane, then the type of systems are nothing but the stable systems. So for example, I am going to based on the poles can divide this system. For example, I am going to here divide the one pole here, and here representing one pole representing with the small circle, and zeros represent with the small zeros, small zero, right? Or else a small circle, small cross is nothing but the pole, this is the zero. So here the left half of the S plane and right half of the S plane, sorry, left half of this one is the left half of the S plane, here right half of the S plane, right side and left side, this is imaginary part, this is the real axis, real axis. So here see, this is the poles, these two poles present at left half of the, sorry, right half of the S plane. This type of systems are unstable systems, unstable system. For example, poles are present at left half of the S plane, this is the imaginary axis, and here real axis, sigma c. For example, poles are like this, P1 and P2. These two poles are left half of the S plane. There is a no pole present at right half of the S plane. Only two poles present at left half of the S plane. These type of systems are the stable systems. Stable systems, simply. These are the representation of stable systems, unstable systems. Okay, now see, observe absolutely stable system and conditionally stable system and marginally stable system. Now see, the first one is the absolutely stable system. If the system is stable for all the range of the system component values, then it is known as the absolutely stable systems. If the system is stable all the range, any parameter or component value, or that is for example k, it is the parameter or component of that system, range from 0 to some value, 200 or 0 to some value, means that value is in the bounded value only, the component or else the parameter value is bounded value, then that type of system is nothing but the absolutely stable system. So absolutely the system is going to be stable when the parameter of that system or component of that system values are in a particular range, they are consist as some particular range. For example, k less than or equals to 0 to less than or equals to some 5, for example 0 to 5 is the range, right? Range of that component. So that type of systems are nothing but the absolutely stable systems. For here see, the open loop control system is absolutely stable if all the poles of the open loop transfer function present at left half of the S plane. See here, just for example, open loop control system, g of s equals to some value. For example, I am going to write g of s equals to poles 1 divided by s plus 1 and here s plus 2. So s plus 1 that is equals to 0, nothing but what, minus 1, s equals to minus 1 pole and s equals to minus 2. So here minus 1 and here minus 2, so representing here minus 1 minus 2, here imaginary and real. So these two poles are present at left half of the S plane. of this open loop control system, then these type of systems are nothing but the stable systems. Simply, so similarly, the closed loop control system is absolutely stable if all the poles of the closed loop control system function present in the left half of the S plane. See here, open loop system or else closed loop system, both are stable when the all the poles present at the left half of the S plane only. Here S plus 1, S plus 2, right? Here S plus 1 in denominator part, that is equals to 0. So S equals to what? Minus 1. So here S plus 2 equals to 0. So S equals to what? Minus 2. So minus 1 and minus 2. The two poles present at left half of the S plane of the open loop control system. Similarly, any closed loop control system poles are present at the left half of the S plane, then the type of systems are nothing but the stable system of closed loop control system, right? So here this is the absolutely stable system or conditionally stable system. Conditional here, the parameter or component value ranges are in conditionally stable condition. Here see, if the system is stable for a certain range of the system component values, then it is known as the conditionally stable system. Particular range of the any system parameter or component consists as the any range of the value, or for example certain range 0 to 25 or 0 to 100, the k value is between the two range only. So that range is certain range of that system is nothing but a conditionally stable system. So conditionally, here is absolutely stable means here absolutely the range of or else absolutely the parameter of system component values or component or parameter values are must be absolutely or else absolutely stable condition, means all the poles presented left half of the S plane only. Here k value some particular range, k parameter, I am going to consider a k is a one parameter that consists as some values or certain ranges we specified. That condition, based on that condition only the system is going to be stable, right? So that's why we call it as the conditionally stable system. If the system is stable for a certain range of the system component values, then it is known as the conditionally stable systems. Say here, marginally stable system. Marginally stable system, if the system is stable, by producing an output signal with a constant amplitude value going to be constant, and the constant frequency also, and oscillates the bounded inputs are going to be oscillates but constant frequency and amplitude, then that type of systems are nothing but the marginally stable systems. For example, I am going to just draw like this. This is the imaginary axis and this one is the real axis. So imaginary and real axis. Now I am going to represent the poles on the S plane. Here S plane. So first pole presented the left half of the S plane and second pole also left half of the S plane. For example, these two poles are left half of the S plane and one more pole presented the right present on the imaginary axis. So imaginary axis. So total 3 poles are available. 2 poles presented left half of the S plane. One more pole presented the imaginary axis. Then these type of systems are nothing but marginally stable systems. Marginally stable systems. Marginally stable systems, right? So if for example I am going to draw like this. This is the imaginary axis and real axis. So one pole present here, one other pole present here, and imaginary axis one pole, and right side one pole is present. So these type of systems are unstable systems. Unstable system. Why, sir? All the 2 poles present at left half of the S plane, one pole present at imaginary axis now. then the system is stable, right? But see, observe the one more pole presented the right half of the S plane, right half of the S plane. So that's why if any one pole or at least one pole presented right half of the S plane, then that type of systems are nothing but the unstable systems. Unstable systems simply. If any at least one pole presented right half of the S-plane, the type of systems are unstable systems. See here, observe. The open loop control system is marginally stable if any two poles of the open loop transfer function is present on the imaginary axis and left side. Imaginary axis only the two poles are present, the poles are present here or else here, imaginary axis and real axis. So imaginary part in two poles, for example here one pole, here one pole, imaginary axis mein two poles are present, then the type of systems are nothing but the marginally stable systems. Next is similarly closed loop control system also. Closed loop control system is marginally stable if any two poles of the closed loop closed loop transfer function is present on the imaginary axis, present on the imaginary axis. Closed loop as well as open loop. Closed loop system, open loop system, poles of the transfer function present on the imaginary axis, then the type of systems are marginally stable. If the poles present on the marginally imaginary axis and also any pole, at least one pole presented right off of the S-plane, then that type of systems are nothing but the unstable systems. Unstable systems, right? So unstable systems. So here these are the basic stable system, unstable system and marginally stable systems. For example, I am going to here draw like this. See, imaginary axis and real axis, one pole present at right side and one pole present at imaginary axis and another pole present at right side. So this type of systems are nothing but unstable systems. Unstable system. Or otherwise, if any two poles present at left side, any two present at imaginary axis, so these type systems are marginally stable systems. If any pole near to the origin and another pole, for example s equals to -1, here s equals to -2, two poles left off of the s plane, this is imaginary and real axis. Here see, s equals to -1, s equals to -2, two poles left off of the S plane only. This is the stable system. Stable system. And also here S is equals to -1. S equals to -1 is the, this is the nearest pole of the origin. Nearest pole of the origin. Then we call it as this pole is the dominant pole or dominant pole. Dominant pole. Dominant pole is nothing but what? If one pole, if any pole near to the origin of the S plane, on S plane, any pole near to the origin, then the type of pole is nothing but the dominant pole. Simply, if for example, I am going to draw like this. Here one more imaginary part, here also one more imaginary and one more imaginary here. Just simply I am going to mention here imaginary axis, real axis, two poles, repeated pole here, repeated poles, two poles here repeated, two poles here repeated. So these type of systems are the marginally also, okay na, conditionally. Oh, wait. So these repeated poles present, then the type of systems are unstable only. Unstable only. Okay. So repeated. So unstable systems. Marginally stable. Marginally stable also repeated. No problem. And also here, marginally means here imaginary. At least one or two poles present on the imaginary axis. Then the and also left side any poles are present, there is no problem. The type of systems are marginally stable. If at least one pole presented right off of the plane, then the type of systems are unstable systems. Repeated poles are present on this unstable. So here, repeated is here only imaginary repeated. So here one more right side one pole is there. So that's why unstable systems. Unstable systems. So all these are the basic system analysis or stability analysis in control system. Base what is mean by stability system. Stability is nothing but the if any system outputs are in our control only. For example, any our vehicle is in our control only, then that type of that vehicle is the control system only. If controlling by who are using that vehicle, just he has to control the all the parts of that vehicle, or controlling under completely controlling that vehicle, or that is nothing but just control system, right? So basically here poles representation or basically divided the system in based on the poles based on the poles just left off of the S-plane all the poles are present, that is the stable system. If any at least one pole present at right side, that is unstable system. Based on the poles only, based on the poles only that we are based on the inputs. So bounded input or unbounded input, finite input or infinite input, like that. So here bounded input is nothing but finite input, finite input or finite out. For finite input we will get the finite outputs, bounded outputs. Then the type of systems are stable systems. Stability of the system is in our control only. The type of systems are stable systems. Simple. See here, see one time stability, and today just we learn from stability analysis from that what is meant by stability of that system and types of systems based on the stability, right? These are the basic idea of stability of control system, and how to determine the stability system based on the poles also, and how to determine the given system is stable or unstable based on the given inputs also, based on the poles and based on the inputs. When the system is going to be stable, when it is going to be unstable, and what are the stability conditions, based on the conditions the system is going to be stable systems, marginally or absolutely stable or conditionally stable. All these are we learn from the today's session, right? So I hope you understood every point. These are the basic definitions and basic representation for the stability of the system or a stability analysis in control system. I hope you understood every point. Thank you all.